Hey, hope you're doing well. I've got a really cool idea that I'm going to share. The stars and the sun and the moon and all the celestial bodies that we see above our heads move. We are told that here's your planet, here's your ball. We're told that the Earth is spinning at 1,000 miles an hour. And we're told that it's traveling around the sun at 67,000 miles an hour. And we're told that it is flying through the universe at 500,000 miles an hour, chasing the sun. But at the same time, you can take something as basic as a planisphere. It's the most remedial tool to look at the sky. This was designed and patented using the Gleason's map, which is a azimuthal equidistant map, and you can set the date and time, and you can see what stars are in the sky. Objectively, the stars rotate around the center of the Earth. Objectively, this clock works perfectly. You can see the second hand is the sun, and it is basically daytime in Australia. And I understand it's not a perfect representation of the shapes of the continents from what we understand, but either is any of the projections that we have, like the Mercator map that we're used to seeing. The land masses don't look exactly like that either. So I'd venture to say it's somewhere in between. But anyways, this is objectively what happens. So I'm in North America, which is right there, and it's nighttime. This is, you can look at it's basically 24-hour period. 10:35. Objectively, what happens is the sun rotates around the center of the Earth and lights up that portion of the Earth and creates daytime. And the sun is close, local, bringing its local light and local heat as it rotates in a circuit daily and rotates around the Earth. What is not lit up is nighttime, and what is lit up is daytime. And that's objectively what we see. And that's why this clock works perfectly. And tomorrow at noon, the Midwest of the United States will be lit up because the second hand and the sun there will be directly over the center of the United States. And that's objectively what happens. So what I'm going to show you in this video shows a lot of these details much more in depth, and I hope you enjoy it. So let's get into it. Okay, one other thing I'd like to add is I ended up putting a lot of information in here, and I wasn't really intending to make it so long, but I just kept finding good, viable information and kept adding in. And I think it kind of goes from the most basic and kind of evolves into highly technical analysis of the details of our natural phenomena and how we explain it in a different way than what modern academia understands with the globe and the heliocentric model. And it gets very technical, and I really strongly encourage you to watch the whole video, and especially as you get into things that might push what you understand or know or even believe. Really look at the information, because it is accurate. It is 100% accurate. And I want to challenge you to look at the information, let it sink in, watch it a couple times, take some notes, go back, because this is really the cutting edge of the evolution of our understanding of our surroundings and our Earth. And there are people that are getting together in a community to discover all of this and to compile all the information as it should. using real science and real testable, repeatable scientific observations and tests and experiments, and it is a wonderful time in the world. So if you're watching this, I'm glad you're a part of it, and we'll dive in. Okay, thanks, bye.
As crazy as this sounds, these rocks aren't glued, tied, or supported in any way. See? But how could structures like this, and this be possible? Let's find out.
So this is just truly amazing. This is the epicycle of all of the planets, and this is objectively how we see them circle over the Earth. And the Polaris would be the center, or the center of the Earth, and above our head, this is objectively what we see. So it's amazing that anybody could see this and think of the Big Bang and how it would be a random explosion, except it's not random. You know, God created an amazing, beautiful place for us here, and all these planets have this spirographing way that they rotate around and follow the same path as the sun and the moon, just at a slower rate to give us our signs and seasons exactly as it says in Genesis, and it's perfectly symmetrical, and it's just a beautiful thing to see. Now I'm going to show you real stars, because planets are nothing more than wandering stars. All of the fixed stars rotate together, and then there are some other stars which are mislabeled as planets that merely take different paths.
Looks like a coin in a very shallow stream of water. Photography, we can see.
So, once you've got your planisphere aligned correctly for the date and time, and you can see here, once you've done that, you then need to find the 4 directionals on the planisphere. So you can see here, west, north, south, and east. So, carefully keeping the date and time the same alignment, we want to put west to the west. So if you can find the sunset, you put your west towards the sunset, and then you simply hold the planisphere up to the sky, and you'll be able to see what's there.
Hi there, and welcome to Eyes on the Sky. My name is David Fuller, and I try to make it easier to understand the science of astronomy and have some fun at the same time. While a telescope is a useful tool for seeing things in the night sky, for the most part they won't help you find things in the night sky. For that, it helps to have another tool, a planisphere.
How's that again?
A planisphere is like having an adjustable all-sky map that both beginners and experts alike can use to see what stars and constellations are visible in the sky for them at any given date at any given time.
Excuse me, but how is that possible?
Take a look at this one. It's made from 2 discs, one with stars printed on it and another with a visible window section.
Okay, so this universal planisphere, this is the actual patent, United States patent, and the inventor is William Eisenhower, and this is the universal planisphere, complete guidance computer system, and here is some details. These are the zodiac stars, and on the outside this is the clock. This is just the actual physical thing, which is this. Okay, it's because it's 2 pieces. So this is the inside. This right here is a azimuthal equidistant map, the Gleason's map, and check this out. You want to see what he cited in his patent, and this works, right? So we know for a fact you can set the dial and go outside and look, and these are the stars you're going to see forever. This was like 100 years ago, and it works, and it would have worked 1,000 years ago, and it'll work 1,000 years from now. And all you do is you set the dial, and all these stars, you spin it around. And what did he use to create this? Let's see, patent citations. Number 1, the 1893 Alexander Gleason map. This is what he used. This is the Gleason's map. Okay, so this is what he used to create the planisphere using this, what we call a flat Earth map, azimuthal equidistant map. And people say, "Where's your map? Where's your map? What does your map work?" Well, it does. It does. Works in the sky. Works for travel. Okay, it does work.
First, notice the window where stars can be seen. This is where the stars show for a given date and time. It also has a latitude listed on it. Now this is important because where the stars will be visible in the sky is different depending on your latitude. Now I live near Chicago, so this 42-degree latitude planisphere is perfect for me. Latitude also changes where Polaris is located for your planisphere, and since the sky appears to rotate around that point for northern hemisphere dwellers, it's where the center point of the planisphere is located. For mine, it places the celestial pole about halfway between the horizon and zenith of the window. So when you acquire a planisphere, be sure to get one that is within 5 to 10 degrees of your latitude. Dates and times are listed as well. When the disk inside is turned, the stars visible in the window change. As they do, we can look at the planisphere and see what the sky would look like if we looked up on that day at that time. But there is a visual problem with most planispheres. For a clue, let's consider the word planisphere. Now it's a compound word from the Latin planum, meaning flat surface, and sphera, also from Latin, which means globe. The term celestial sphere was coined because when we look up at the night sky, it looks like a half globe, not a flat plane. Makes sense, right? So now think about planis, sphere, for a second. Planis, flat, sphere, globe. Planisphere, flat globe.
Say what now?
Uh-huh. So how about a visual? This orange peel represents how the night sky might look to us if we were really tiny and underneath it. And if the sky was white. And smelled like citrus.
The Flat Earth Sun and Moon Clock App. A dynamic new app to teach family and friends about where they actually live. The sky is a perfect clock. The sun measures the hours and days. The moon measures the weeks and months. The star constellations measure the seasons and years. 12/12 or 24-hour clock face, or go hands-free. The Flat Earth Sun, Moon, and Zodiac Clock App with new added features. World Time. See what time it is all around the flat Earth. A true Earth compass that shows true navigation across and around the flat Earth plane. Weather. Tap for detailed local weather information. Know what phase and where the moon is at all times. Watch the sun travel between the tropics for the seasons.
The recent weather has been weirdly warm, but what happened Sunday evening seemed to defy logic. One glance at this picture and it would appear the sun was positioned below the northeast horizon. Light seems to be emanating from behind the mountains, but it was late afternoon, and the last time I checked, the sun sets in the west. Indeed, the sun was setting low in the southwestern sky, but shadows and light from a mix of clouds and the sun made it appear like the sun was setting to the northeast. Crepuscular rays are beams of light that appear to converge on the sun. You've probably seen these beams of light before. But what happened Sunday evening was anti-crepuscular or anti-solar rays that converge in the opposite direction. And you must have your back to the sun or sunset point to see them. The low clouds in the foreground are lit up by the sun. Shadows behind these clouds extend out towards the horizon opposite of the sun. Anti-crepuscular rays are a meteorological optical phenomenon. They are essentially parallel, but appear to converge towards the vanishing point due to visual illusion from linear perspective.
Eyes to see. All celestial phenomena explained on a plane Earth. Let's get it. So, one of the most famous things that is commonly said as to how the Earth cannot be flat is that when you look in the south, the stars move clockwise, and in the north, they move counterclockwise. And they claim this is because you're antipodal upside down on a ball. And that's the only way that it could happen. So we have the star trails here, and they say that this is impossible and debunks flat Earth. Let's see if that's true. So here is a nifty little model made by someone by the name of Walter Bislin, and it explains all celestial phenomena on a plane Earth. This includes eclipses, equinox positions of the sun and the moon positions throughout the year, visibility of the sun and the moon, directions of the sun and set and the moon set, the fact the sun doesn't change angular size, southern star trails, all positions of the stars, everything. It explains everything. Very interesting. This was done by an anti-flat earther. Here's the truth about this story, by the way. He worked on this for a long time trying to debunk flat earth. He found out he really couldn't once he took the azimuthal grid and put it on the flat earth. So he kind of just gave up and said it would be impossible because light would have to bend. Okay, so let's look at some of this so you guys can start to get an idea of it. So this is, of course, a local sun and moon moving over top of a plane Earth. Of course, the sun would not light up the entire Earth. That's ignorant. Yep, has a radius of light. And there's something called attenuation of light. Light does not travel forever. That's an insane, absurd claim. So, seems pretty simple concept here. Let's move on. So you have what's called an azimuthal grid of vision. You can only see so far. You have a limited view in all directions, 360-degree field of view. And this is what we see the world through. through the lens of our personal, people have coined it, dome. More specifically and more accurately, it is an azimuthal grid of vision or observability. Azimuthal grid of vision. We will cover what that means. So here's another depiction. As you can see, we view the sky through this azimuthal grid. There's Polaris at the correct angle relative to that latitude as the stars move over top. So here's an idea of what's going on with the positions of the sun relative to latitude. As you can see, the sun changes position throughout the year and, of course, changes position relative to your latitude. This right here, if you were to view the sun at a certain time of the year, you would see that in certain areas on the earth, you see the sun for 24 hours. Makes perfect sense on a flat earth. Now, you always see it close to the horizon, which it seems like it should actually go all the way up in the sky and stay there on a globe, but no, just coincidentally, the globe always favors what would have to happen on a flat earth, just like the ISS doesn't go over either of the poles, but whatever. So you get a basic idea. We have a dome potentially over top of the Earth. It actually seems like a layered magnetic field. A toroid, we live in a sphere, not on one, on the plane through the middle. But we have a personal dome, and that is the important aspect to really wrap your mind around. You cannot see forever, and we have curved eyes, curved retinas. We, of course, see in curved visual space. We have a limit to our perspective. We can only see so far, and we have a 360-degree field of view. Okay. So here's basically how you can look through your azimuthal grid. So here is how the azimuthal grid works. I put this little video together for you to understand it. So as you see, you look out forward, you have a curved visual space limit ahead of you. Of course, this would be you looking up on the right. If you looked up, this is what you would see. You have a curved visual space, an azimuthal grid of vision. Here is the depiction of how that is established. So you have your zenith directly above you. The line that connects through that is called the meridian. You then have your celestial object or your star, and you take an altitude angle to that star. Of course, in order to do that, you establish your azimuth on the horizon. Your azimuth is the direction established on the horizon. You take your altitude angle to the star. When you do this, is you'll end up mapping out positions all around you, right? And you'll get a dome. This is called an azimuthal grid. It's based on real life angle measurements to the sky. And that is how we map out the sky. That's even how Time and Date and Stellarium does it. The Globers take this fact that that's how we map out the sky with a flat horizon mapped out to the azimuth angle. We take altitudes from that and we make an azimuthal grid. And then they try to force it down a globe's throat. And in fact, this is how they engineer the globe. I take hijacking our perspective. Okay, so now you guys know what an azimuthal grid is. Hopefully that makes sense. Pretty simple. Here is another depiction so that you fully understand. Anyone denying this is denying objective reality and how we make measurements of the sky. So again, you have your zenith, you have your horizon. That would be you establishing your direction with your azimuth, and then you're taking altitude measurements up from that, and then you're going to map that in all directions, 360. You get an azimuthal grid. Here is the observer and what he can see so that you understand it. You have, of course, 360 degrees all around you. This is how we see the world. Again, here's another depiction. Again, you have your zenith. I want to really drive this home, make sure everyone understands. Pretty simple. The observer standing in the middle, like right here. Okay. You're standing in the middle. You could turn around and you can see a certain distance in all directions, 360 degrees. This is how you're seeing inside of this curved hemisphere, if you will. And of course, we're going to take our position to the star based on our azimuth. So an angle up from the position on the horizon, establishing your direction, called the azimuth. And of course, you have the zenith right above you. Okay, now, simple proofs of the fact that this is obviously how we see. So these clouds are obviously not actually going down to the earth. The clouds don't come meet the earth. They just look like they're going down to the earth. Those clouds aren't actually going down to the earth, though. It's just inside your azimuthal grid of vision. It looks, once it reaches the edge of your vision, the limit here, it's going to look like it's going down because it's on a curved limit of your visual space. So that's why it looks like it's going down. That's how perspective actually works. Here's another example, which is hilarious. Shout out to Clay, show me this. I guess the clouds are going behind the curve of the earth. Or maybe it's simply perspective and things drop down in the distance due to perspective and how we view in our azimuthal grid of vision. Isn't that probably what's going on? Or the clouds are on the earth. I don't know which one. Here's another depiction so that we understand this is just a product of perspective. They have hijacked perspective in how you see the world, claim that it's a ball with straight lines coming from your eyes. Pretty simple trick, but also very effective because it was engineered on observed phenomena. So you can always point to the observed phenomena, and ignorant people think that proves the model. Okay, let's move on. So here's where it gets very interesting for the ballers. It's going to be okay. I promise. The fact that the Earth's not a ball isn't the end of the world. A lot of us kind of had this visceral reaction at first. That's crazy. That's stupid. Wow. I can't even imagine something like that being true, something that big and crucial and fundamental or foundational to everything I think I know about where I live and stuff. Like, that's insane. It's going to be okay. I promise. We're all here with you. We all went through it. It actually becomes a realization that it's a beautiful truth. It's really not that huge of a deal. Sure, people are going to ostracize you, but just look around. People were scared of the air for 3 years. Do you really want to fit in with everyone else at this point? All right. So here is a phenomena called anti-crepuscular rays. Now, according to the globe, these rays are parallel. And when we look over here, we see that 180 degrees away, we see it look like it's converging down to a point. These are called crepuscular rays and anti-crepuscular rays 180 degrees away. Okay. So even the globe has now been forced to acknowledge this. Has been forced to acknowledge the 360-degree field of view azimuthal grid of vision. And based on perspective, it looks like it's doing something that it's not behind you, basically wrapping around you, giving you an optical illusion of convergence where it's actually not, where it looks like there's a point here that isn't actually there. Moving on. Here is another example. You have the crepuscular rays. We're going to pan the camera over our head, then back down to the horizon, and we're going to see the anti-crepuscular rays. Okay. Now, this is also very interesting. So you look at the crepuscular, you have the anti-crepuscular. Now, this is a depiction here. You see what the light is doing. Optically, it looks like it's curving over top of your head, right? It looks like it's a dome, like it's curving over your head. Now, the globe Earth claims that these are parallel, and they just look like they're converging to your left, look like they're converging to your right. They shouldn't be curving over the whole sky. They should look completely flat over top of you. Fundamental difference in understanding here. Once understood, this is a irrefutable death blow to the globe Earth model. And that is the irony of everything. Okay, so we have crepuscular and anti-crepuscular rays. Again, on the globe Earth, we must claim that these light rays, this is an optical illusion. They're actually parallel from 93 million miles away. And it just looks like it's converging on the other side, but the sun is 180 degrees behind us. So even the globe Earth has to claim a 360-degree field of view optical illusion with anti-crepuscular rays. Very simple stuff. Okay, and again, it should be straight over our head on a globe. So again, just to understand what it is that they say that the light rays from the sun are basically like these railroad tracks, right? And this is just the optical illusion of convergence, right? If they keep going the distance, they're going to appear to converge. So they claim that these rays are actually like railroad tracks. So if I look this way, I'll see optical convergence. If I look behind me, I'll see optical convergence. But in reality, they claim that they're parallel, right? Now, if I step back from this phenomena, I should never see them curving. According to them, they should be parallel. Like if you stand in the middle of a railroad track. You stand in the middle of this railroad track and you look this way, then you turn around and look the other way. Well, you see the railroad tracks close to you are 180. Now, another problem is this has to go over your head. because we see the light over our head then come back down optically to the horizon. And here they explain the sun calc, and look how they calculate our optical perspective of the sun on a globe. Suncalc.org. This is the Weather Channel explaining anticorpuscular rays and how it's just an optical illusion. And look at how we perceive the sun according to the official explanation from the globe. Yeah, isn't that interesting? It's almost like we have an azimuthal grid of vision that forms a 360-degree field of view dome in all directions. If you deny this as a globe earther, you deny your entire belief system, and you must now do away with the globe anyway. Okay, now how interesting is this? And this is where we are going to really lay this out. As you see in the top left, you got a dome, and you see these two lines appear to move in towards each other. If you look on the right, you also see this light appear to bend towards the top of the dome, towards each other, curving. Now, if you look very closely here, this is a real picture of the Earth. You will see light rays coming up from down below, coming up, curving over, and coming back down. Wow. How's that work on the globe? I thought that this was an optical illusion. These were all parallel rays. Okay, then they must just converge. They can't curve, though. So why are they curving? Now, of course, in a personal dome of vision, more specifically an azimuthal grid of vision, that is exactly what you would see. Oh, what a coincidence that exactly what we would see is literally what we see on the Earth. Now, this is a personalized grid of vision. Okay? It's nothing to do with the dome over the whole Earth. The dome wouldn't be that small, would it? Okay, this is our personalized dome. I need all the flat earthers to listen, please. You guys have got to get this. This is the end of the debate, definitively. All right, let's check it out again. Look, this is just a dome. Now, we'll be doing further demonstration observations and experiments, breaking this all down in the future with different angles and different effects and phenomena replicated. This is a real picture of the Earth that shows the curve. They should be parallel, only optically convergent. They should in no way be curving in a singular line down to an optical illusion of convergence down on the horizon on a globe. Here is what it would look like exactly in a personalized dome of vision. Let's move on. These are going super fast. Here's another one. Here's another one. Now, what's up with that? That's pretty interesting. It's almost like now I might need to come over here and talk to you guys. Look at the circle, okay? Why do we see a circle above us? Why are rainbows actually circles? Why are rainbows circles? I'll show you. Now we have a personalized dome of vision, curved visual space, right? This is how it would look looking up. You see here on the left, you of course would have circles on the interior of the azimuthal grid that are getting smaller and smaller and smaller as it goes up. So this is what you would see. You would literally see circles based on the edge of the dome that you see. So the right is what you would see looking up. The left is what you would see from the outside. You would have circles that get smaller and smaller going up. Understanding that with this, okay, we have circular eyes. We have visual curved space. There's no other way that we could possibly see the world. Physically speaking, we have curved retinas. We have curved optics with everything that we use, even pinhole cameras. Everything is curved. That's how we see the world. We have diffraction interpreted through a curved, concentrated point. Okay, so we have curved retinas, curved eyes, see the earth and everything in the world in curved visual space. We have an azimuthal grid of observability vision, 360-degree view. And I know I'm saying these terms a lot, but I want them to click with you and for you to understand them. Now, when you add the Atmos, what you're doing is effectively throwing this in front of your eye or putting glasses on. You're exaggerating the effect of your curved visual space, how you visually see in curved space. You're exaggerating that with the Atmos, acting like a lens. Exaggerates it. That's why when it's clear outside, you can see further. That's right. contrary to the baller saying, that's when everything is refracted and lifted up over a ball. Okay, let's keep going. Now, if you see here in the top right, you will see, look at that. The arrow goes the opposite way because of the water. And of course, you see the light in the fish tank. Now, what it's actually doing is it's actually exaggerating and exemplifying how we perceive the world through curved visual space. It's an optical effect. There is no physical bending of anything. Okay. Now, again, here we have the crepuscular rays, comes back around to anti-crepuscular rays. And here is a depiction, right? If you have, again, you would have curved light over top of you. And now it just looks this way because that's how you view the world. And here you have counterclockwise movement and then clockwise movement based on which way you're looking at a rotation through your curved visual space, personal to you. Well, that's exactly what we see with the southern stars. It's exactly what we see. If you look in the top left here, you will see, I cannot believe that there's no sound. I'm still so salty about that.
Okay, so watch this. There it is. Sun's above your head and then it sets. One more time. That's exactly what is happening, okay? Let's change latitudes now and let's go to the North Pole. If you go to the North Pole, the North Star would be directly above your head at your zenith. So if this is the latitude of 45 degrees, because if the equator is, okay, so watch this. See now it arches. It's going this way because the sun is at the degrees. The North Star would be here, okay? So if you're at 90 degree north, the North Star is 90 degrees above your head. 40 degree, then it's 45 degrees above your head. Now, if you're at the equator, the North Star would be directly 90 degrees. You wouldn't even be able to see the North Star if you go past the equator. See? Watch, I'm gonna show you. But first, you're gonna see how it looks. See, now it arches. It's going this way because the sun is at the equator, but you're not at the equator. So the sun doesn't go directly above your head. It does this arc, it does a curve instead of a straight line. So the sun would never do a straight line at the North Pole. It would always go around you, and the sun would never do a straight line going above your head. The sun would always be turning at the horizon at the North Pole. So the sun never sets in Sweden and Scandinavia during the summer. It keeps going around the horizon, and it's never above the head or below the horizon. It's at the horizon. Sometimes it's twilight where the sun is below the horizon, but even though it's below the horizon, you still get light because it's not a ball. Well, peep this out, guys. This is very interesting here. Look what happens when we go past the equator and we go to the South Pole. Boom. The South Pole is near the horizon. It's never above your zenith unless you go to the South Wall, which we're not allowed to go there. So no one ever takes pictures of the South Pole directly above your head except for the Army. And that South Pole going the opposite direction is just a reflection. This dome is reflective, and as that turns this way, like that, this goes the other direction.
I told you that this was quite literally game over for the globe, and it explains every single celestial observation. I'm not joking. All right, you gotta pay attention. Of course, PAD here stands for personal atmospheric dome. And in reality, the light is not even physically bending. It's an optical effect. This is a very key component. This is the missing piece to flat Earth. Okay, now I'm sure you guys have seen this nonsense This is not a Professor Clown show here. Saying, how could all these three observers see the Southern Cross at the same time if they're all looking in different directions? And so many people think this is a slam dunk against flat Earth. Well, not so fast, buddy. First of all, these are improperly drawn angles. They are not looking this way at all. So keep in mind what this looks like. See where this guy's looking way out here, this guy's looking way out here, and this guy's looking way out here. They can't see what you're showing in reality at these positions, looking at these angles. That's not what happens in reality. So let's look at what happens in reality. Okay. So they're seeing them not directly south, but two of the observers are actually seeing them southwest. Southwest. Okay, which is what we would expect. Let's go on to the next one. Now, here are the actual positions of what you see from those locations. Now, as you can see, if you look real close, and I hate that it's not bigger, I'm sorry, it won't let me play it. The positions are different. Look right here, and right here. We have a bigger visualization in a second. And look at the different times, 5 a.m., 11 p.m., 6 p.m., and you see them in completely different positions. So it's not some one place you look down at the bottom of a ball and you see it. The irony is that this straw man is about to backfire so hard on the globe. We're going to demonstrate it's actually impossible on the globe. It's only possible on a flat Earth with a personalized azimuthal grid. All right. So one of the questions that everyone wants to know and wrap their mind around, Sigma Octantis, how does it quote unquote maintain its position and stay in the sky? Now, first of all, they say you can't see this star with the naked eye, but telescopes have seen it, observatories have seen it. Well, that's convenient. Let's just say it's real and you can't see it with your naked eye, but it's really there. Let's just say it is. Doesn't matter. Doesn't help you out. It doesn't stay in the same place. It moves in the sky. Okay? It completely moves in the sky. It does not stay in one place. It changes position in the sky. How does that work? How's that work? Okay, let's move on. Oh, wow. Okay, so to make sure that you fully understand it, just like these anti-corpuscular rays appear to be converging to a point, this rotation over top of you, all going around Polaris, you look south through your personalized azimuthal grid of vision, and it looks like it's going the opposite way due to perspective through the azimuthal grid, and it looks like it's converging into a singular point, just like anti-corpuscular rays. It quite literally has to be the case because we see it happen everywhere else in nature. That's why we have a specific point of convergence, which again actually changes position in the sky relative to the observer and the time. Oh, it's starting to look like this can only work on a flat Earth. Oh, it gets worse. It gets worse. So again, we have the alleged home run that we have counterclockwise in the north, and we have clockwise in the south. Well, check it out. You have your personalized dome. Now, don't worry about the scale here. You see, this is what you would view just like with the corpuscular and anti-corpuscular rays. You would see in the middle of your personalized view. Now, it's all relative to the actual stars moving over top of you in seemingly a plane. You're going to perceive this optical convergence in the middle, going straight, meeting in the middle, and then converging at a point on both sides of your dome relative to the motion above you. So if we look at the corpuscular and anti-corpuscular rays, they would meet in the middle. Because look, say we're at the sun setting. So we're looking in the west, we're seeing where the sun is setting, It looks like we have crepuscular rays. We turn 180 degrees over here, and we see anti-crepuscular rays. If we were to, now we follow them from side to side over our head. Remember the videos. Now, if we were to take them out, what they look like they're doing, and have them meet, right? Well, they're going to meet in the middle, and they're going to create a straight line where they meet. So this is a product of perspective. It has to be. We see it happen on the Earth with anti-crepuscular rays. There's no other explanation. This is what you would see. We see it with anti-crepuscular and crepuscular rays. They have to optically meet at a point. This is what you would get. This is what we see when we look at the stars. That is certainly not a coincidence. Here you go, side by side. This is all a byproduct of perspective we see in 360-degree visual space. So now we have the stars moving over top of us. We're looking out in each direction. Now, of course, we can't see the same stars from all these positions or something, but it doesn't matter. These stars are all moving in one direction over top of us. We're looking south in our azimuthal grid, and we're going to see an optical effect relative to our personal view. So this is what each observer is going to see because of the effect of the optical convergence down to your limit of the curved dome, if you want to call it that, so that it clicks with you. I don't want to call it that because, accurately put, it is an azimuthal grid of vision or observability. So again, here we go. You would have Polaris, and then you would have what they say is Sigma Octantis that can't be seen with the naked eye. The optical convergence, just like we have with the rays. So just like we have with crepuscular and anticrepuscular rays looking like they're meeting at a point, that's what this area around quote-unquote Sigma Octantis is. It has to do that. It has to converge down to a point just like the crepuscular and anticrepuscular rays do. Once this clicks with you, honestly, this is just such a welcome to flat Earth. I hate to break it to you. Because we're about to explain. We've already explained one of the problems in brief passing as to why this actually debunks the globe. But we're about to get into a little bit more detail about that. So just kind of soak it in. I know when you first see it, it's kind of hard to wrap your mind around for some people. I understand it. But once you really put together how the crepuscular and anticrepuscular rays work, I think it should help you click. Again, where you see the optical convergence, again, the optical illusion that there is convergence going the other way, because you're looking in the opposite direction of rotation, just like you're looking in the opposite direction of where the sun is. And then based on your curved visual space, like we see with sundogs and we see with halos and all this, you're going to have an optical point of convergence going around a singular point that people call Sigma Octantis. Okay, next. Now, here are the actual positions of these stars that they think is some type of home run. And they draw their arrows out south and act like it's a home run. Now, look, this is south right here. Now, look, this is a little off of south. You see the Southern Cross right here. Now, look where it is in the sky. You can look down here at the time, right? So if you see the time down here, we're going to keep the same time for every single observer. Again, you see the stars up here. Let's look at the next position. It's down here on the horizon at the same time. This is the part of the Southern Cross that people are bringing out. Why can they all see the stars in the same place in the sky looking in the same direction? Well, they don't. They actually don't. They see them south-southwest in different positions and angles in the sky at the same time. Now, look where this one's at the same time down here. This one is all the way up over to the right, very close to southwest. Okay. Same time, same star. You see right here, this is the name of the star. You'll see that it's a star for every one of the slides. Okay. Now check this out. So we're going to look, if we look at different times, this is when we see the position of the star closer to south. Okay. Now here you go. All observers see the same constellation while looking southwest. How does that work on a globe? Now, mind you, let me just make sure you guys are reminded. They claim they all look directly south. They see the same stars at the same time. They straw man where they're actually standing and looking and what they see. They say everyone sees the Southern Cross up at the sky, same stars, same place, same time, same direction. In reality, They do not. They see them again, same time, up here, down here, up here to the right. How does this work on a globe? We're here looking southwest. When we're looking at the actual direction that the actual observations are, the star is supposed to be, what's going on? Why are we not looking at the stars? Huh. So the Globers got some explaining to do, I guess, because there's supposed to be optical convergence over the South Pole, right? This is supposed to be a circumpolar rotation on a globe. Yet here we are looking away from that area when we actually put the real data of the observations on a globe. Uh-oh. Looks like that backfired a little bit. The irony of how this has totally backfired on them. This was their home run. Flirts are so stupid. Blah, 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 blah. Okay. Well, feel free to enlighten me exactly how this works. All right, here. At least you can see this visualization now. You guys can't hear the music, sorry. There you go. You see where the positions are. These are at the different times, right? 5 a.m., 11 p.m., 6 p.m. You see here that we're going through the actual positions. Now, of course, everyone should know this. You're constantly updating relative to north whenever you establish your directions of east, west, and south. Dun, 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 dun. I forgot you guys can hear it. Again, here we go. This backfired, but you know what's new. If you're not new to Flat Earth, you know that's kind of what happens every single time they claim to debunk Flat Earth. So here we go. Photographed from near the Arizona Sky Village, looking west to the setting sky. Oh, StreamYard will at least let me play music, I think. Tell me if you guys can hear the music that I play. Really soak in that the ways, the directions are that you're looking. Arizona, Australia, looking south down here. Of course, see the way that the stars move. Oh, the beauty of taking the best alleged globe group and just shoving it back down heliocentric model's throat. There we go. Okay, very interesting. So here we go with the star trails mapped out in this program. And you see, if you're looking out over the plane, you see that you have just star trails all coming from Polaris. Now they say this is what it should look like on a flat Earth. They say that we should see... They say that we should see all of these stars just like this. Where can we find Walter? He's an anti-flat earther. You're not going to find him. Are you talking about Walter Bislin? Yes. Yes. Now, once we add the Atmos in the program, you start to see that the star trails perfectly match everything now. It is important to fully grasp this part. So, in fact, this is, again, what I showed you. We have the personal vision, the azimuthal grid of vision, and then the Atmos. What does the Atmos do? The Atmos actually does this right here. So it exaggerates the effects of your personal grid. Just imagine taking a pair of really thick glasses. So take a pair of thin glasses. Now take a pair of really thick glasses, okay? And that you're putting the atmosphere on. You're looking through your vision. It's important to understand, when we account for that in this program, immediately, all of a sudden, star trails that are all going in one direction around Polaris, the program makes them match reality. Wow, what a surprise. You guys see how it matches exactly what we see as soon as we account for our personal vision? An azimuthal grid of vision, an arc of vision. We have curved visual space. I'm going to keep saying the phrases until we understand them, and this is literally the end of the globe as we know it. Not that that hasn't been the case for years now, but this is literally ripping 95% of their alleged evidence out of their dead hands and actually flipping it on them and then loading the mag and then unloading it. It's pretty brutal for them. Of course, we have the curved visual space. Again, the Atmos actually exaggerates and exemplifies that effect. And then what do we get once that happens? We get this. This is what we get. Look at it. Take it in, Glovers. Dun, dun, dun. Here we go. All the stars radiating out from the center, all moving in the same direction. Here we go. Mapping it out. And we see, so again, just so you guys get it real fast, you see, this is what we see. We put it over top of the Earth and we add the Atmos. And then, of course, that's actually exaggerating our personal limit of our view, because perspective is a real thing. You can't see forever. As insane as that is, people actually seem to think it's real for some reason. They actually think they're looking back in time with telescopes. So what can you do? This is what we get. This is not doctoring anything. This is just reality accounting for layering the Atmos with perspective. And when properly defined, you have an azimuthal grid, curved visual space. What a coincidence. All right, let's move on. So here we go again. So if you look here, you look through a dome and you have these concentric circles with the dome over top of it. What do you get? Oh, look at that. It makes the concentric circles look like they're warping around and then create an additional convergence point around a single area, just like we see in reality. Wow. Who would have thought? Almost like we can demonstrate it. So let's look and see how the stars would appear when we're looking at them through the atmosphere, through our azimuthal grid of vision. Wow. Look at what the dome. Now again, to make sure everyone understands, each observer has one of these. Okay, just so everyone understands. Someone asked, is it a dome inside the flat ceiling? Okay. We again, I want everyone to understand it. Okay. So there could be a dome over top of the whole Earth. It looks like we live inside a sphere. There's a toroid. Looks like there are layers to it, and that could effectively be interpreted as a dome. That's what it would be. We live on the plane. We see the top half of it. Sure, you can call it a dome. So of course, this is what you would see. Yeah, sure, call that a dome. Call the top half of this a dome. That's cool. Sure. This is different than that. This is our personal vision. Okay. And when we look through our dome of vision, our azimuthal grid, which is literally the reason we know this is real is because we've taken angles to stars all around the Earth, and this is how they look from everywhere. We get our altitude angles, like I covered in the beginning, and we get an azimuthal grid. That's how we see the world, and we can prove this with railroad tracks and corpuscular and anti-corpuscular rays and sundogs and halos and perihelions or whatever it's called. All of the celestial phenomena that we see shows us that this is how we see. There's no way around it. So, understanding that, you have the dome. Well, you would have, if you drew around the edge of the dome, you would draw circles. That's what you would get, and they would get smaller as you get higher. Okay, now this is just your personalized dome. You have circles inside of it. If there's a greater dome, well, that's a different thing. That's a different thing. We have a personalized azimuthal grid, provably. I get that I believe that there is like a celestial firmament, okay? But that's not what, this is about how we see the world, okay? Look, here's the demonstration. This is personalized to the observer. You have to understand, guys, if it was just one giant dome, then it wouldn't be the same perspective and ratio for every individual observer. This is how we personally see with an azimuthal grid. The missing piece to flat Earth. Flat Earth has got to absorb, understand, and then begin to integrate it into their understanding when they talk to people. Looking north, looking south, equatorial view. You think it's a coincidence that when we look at concentric circles through an azimuthal grid or a dome, that we get the very exact same manifestation? Of course not. Hey, I want you guys to pay attention. Look at the dome. Look at the dome. How we view home. Look at the dome. Look at the domes. Look at that, bro. You think it's a coincidence? Seeing an azimuthal grid. They hijacked perspective. They said that you lived on a ball. They took our consistent limits to view and perspective, reverse engineered it into presupposed physical convexity of a sphere with water bending convexity around the exterior via their god gravity coalescing it, holding everything into place, but we can't define or explain it. It's pretty simple. Turn around and be like, oh, the sky matches the globe is ridiculous. That's what made the globe. Look at this. Just take it in. You have a personal azimuthal grid. This is how we see the sky. They have nothing. This explains positions of eclipses, equinox positions, sunset positions, sunrise positions, moonset and moonrise positions, southern star trails position of all stars, everything. look at the stars to the right and the left. Yeah. This is how we view the world, ladies and gentlemen. So at the equator, we have this. Of course, now imagine being on a globe looking in a singular direction, standing on a globe that's spinning a singular direction, and then seeing stars simultaneously go in different directions. Of course, the Earth can only be spinning one way. So how do we look straight out at the equator and see this? Because we have an azimuthal grid of vision. This is how we view reality. You have concentric circles of rotation going around the central point that is Polaris, all recorded history over top of you. And as you begin to look at the equator, look south, you'll see the optimal convergence points within this azimuthal grid, which is why when you look at the equator, you see both sets of illusory rotations. So if you took a time lapse of this, you would get the star trails that we just saw, of course. Okay. There's one more. This is the azimuthal grid, looking at south, looking at the east. Or west, of course, the equator. This is impossible on a globe. We're looking in a singular direction while the Earth spins in a singular direction, and we're seeing multiple different rotations in the same direction, the same singular direction. There you go. Here's a depiction for you. Dun, dun, dun. Oh, sorry if the music is loud. Perfect circle time lapses make perfect sense. Actually, I have gravy for that on that as well. Okay. This might be. Okay, now look at what we just saw. Let me actually come over here and make sure you understand. Okay, so yes, we have star trails. Okay, now the cameras are actually engineered. You don't actually sit out there. It takes 2.5 hours to get star trails, right? Because I do them all the time. At least I used to. Takes 2.5 hours and you can't touch the camera. You're definitely not tilted, wobbling, spinning, shooting through space, taking star trails. The ISS isn't going 17,500 miles per hour, going around the Earth every 90 minutes with all that change in pitch and angular direction constantly, 17,000 miles every hour, 5 miles a second, taking a time lapse while you see the lights on the ground, not moving at all, not being blurry, just all moving in a singular direction. That's all fake news because you can't even touch. If you've actually used a camera to take time lapse, you can't even touch it. And any little light that gets in the way messes up the whole picture. It takes 2.5 hours. Now, obviously, the stars don't do a full circle in 2.5 hours. So it completes the circles based on a program. That's why it's a specific setting in your camera. Anyway, so if you looked at the visualization that we just had, now look at the real stars. Again. Just to make sure you guys really are grasping it. Here you go. If you're looking at the equator, you'll see them moving in both directions away. How does this happen on a globe? The globe can only spin in one direction. We're supposed to be swimming in stars, so we should see them all moving in one direction relative to singular position of the observer. Never, ever got an answer other than it's just panoramic. No, when you just look straight at the equator, you see them diverge away from each other. That's impossible on a globe. And here you go again. Okay, now we saw this. Now pay attention to what the stars actually do. Let's compare it to reality.
if we get back to what we were talking about let's talk about the truth. We covered like this crazy idea that everyone just assumes to be true because they were told it when they were like 5, and people are scared to not fit in, or they're scared of looking stupid or whatever, so they just have to attack other people for it. But whatever, I mean, who cares? We're just going to try to figure out the truth. So let's get back into what the Earth really is. We figured out that it's clearly not moving and it's a plane, right? Well, we get back to this geometry that we see in all of nature, and we know that any true theory of physics that's going to really progress us is going to be a theory of everything. Everything's going to have to be connected. Well, it is all connected. There's a common factor, vibration and charge, what people call charge, elementary charge even, right? So everything's electric and everything is vibratory. And this is where you would get this depiction of where we reside. We have a magnetic field in the Earth. We would live on that plane right there. And then basically you would just have the ripples within this geometry going out around us. And so now, again, this is not the proper way to go about it, but this is what people do. Like, oh, well, I can't address any of these direct refutations, or I'll just beg the question over and over and just say refraction, and that doesn't even address most of them. They'll just start asking about flat Earth. How does day and night work on the Earth if it's flat? Like, okay, there you go. Let's check it out. Oh, look at that. It's almost as if we can just perfectly replicate day and night on a plane Earth. Okay, well, I don't think we can claim that. And people are like, oh, well, why wouldn't it light up the whole Earth? Why is it not lighting up the whole Earth there? A local light source wouldn't light up the whole Earth. It's just a ridiculous idea. Day and night works perfect on a plane Earth. What about the summer solstice? Oh, look at that. It matches exactly what the demonstration does. It works perfectly. Look at it. And interesting enough, you see the geometry in both scenarios fits right within that geometry we talked about earlier. Yeah, because everything is that geometry. That vibrational resonance creates a torus field. Hopefully all the other streams are running good. Okay, well, what about when we see the sun set and it should set in a different location? Well, we actually can't see forever. We see in a circle around us, and we're not Superman. We don't have X-ray vision. We can't just see forever, right? We have a limit to our view, and what that causes is basically like a dome around us, an azimuthal grid, right? We can't see forever. So what happens, and we can replicate this, you can take a light source and you can put it over top of a dome, and you'll see that there's different locations. In fact, let me see if I can see it here. You see, if you look closely to the dome, you see there's a light source here. So if this was the actual sun or light source, if you're inside the dome, you're actually going to see this. So as this moves across, you're going to see a different location. It's very easy to replicate. It's crazy that people don't get this. But so as you see here, the actual sun would move around, and then it would cause it to look like it's arcing over top of you, just like we see with crepuscular, anti-crepuscular rays, rainbows, sundogs, etc. Right? It's just we don't see forever. We basically see in a little dome, and that's because our eyes are spherical, and everything is the same geometry. You have torus fields everywhere, elongated sphere of a torus field all over the place, and that's why you see this. So yeah, the position of the sun and all the stars and the moon are all perfectly explained on a plane Earth, understanding that we have a perspective that limits how far we can see. Okay, now here is the sun position data from longitude observations all along one longitude projected onto a plane surface versus an actual pinhole camera long exposure of the sun for a year. And so when we rendered it through the computer, taking all the data measurements of the Earth on one single longitude, this is what it gave us. That basically, this fits right inside the torus field. Again, we're always in the torus field. And it's funny how it perfectly matches the actual pinhole camera long exposure of the sun over the course of a year. So look at that. The year data matches perfectly on a plane Earth again. So here we have a Farrell cell image, of a magnetic field. You see the actual geometry, the lines here. And we won't get into the complexities of the magnetic field, but I'll cover magnetism sometime soon. And then you have here, look, this apparent pattern that comes from the solar eclipse. It's exactly the same. Of course it is, because everything's intrinsically electromagnetic. And so this works perfectly on the plane Earth position. Here we have all of the quote-unquote planets and how they move in relation to us observing from the Earth. Oh, look, it matches perfectly with the Farrell cell image. It's a beautiful, perfect, sacred geometry, flower of life, fits within the torus field. And this is exactly what we would expect to see because that's what everything in nature shows us. So if the Earth is in the center and not moving, this is what's going on around us. And this is literally what we see. And of course, what they say is, oh, well, it's just an illusion. And actually, we're flying around in here too. Okay, so you see that pattern, how it directly matches? This is all the quote-unquote planets and stuff moving around the Earth. Here is Mars from a quote-unquote geocentric position, right? So with the Earth not moving, this is what you get. Oh, it perfectly matches. And this is actually Kepler's little-known diagram here on the right. This is Mars in the Tycho Brahe model. By the study of the orbit of Mars, we must either arrive at the secrets of astronomy or forever remain in ignorance of them. And that's what Kepler said. And it's interesting. I mean, look at what it does. It fits right within this torus field geometry, bro. It's actually very beautiful. And here are all of them. You have Mercury, Venus, Mars, Jupiter, Saturn, which are seemingly wandering lights at a lower density layer. And then this is the quote-unquote ISS trajectory right here put onto a plane. And it perfectly matches. You have, look, here's another depiction of Venus and Mercury. All of this fitting right within the torus field geometry. This is a Farrell cell image of a magnetic field again, right? And this would be a top-down view. You have the vortex in the middle. Then you have these patterns, this motion coming through. Like basically you have these little ellipses that would fit inside there. And then the plane would be cut right through the middle horizontally, but this is top-down. I threw this quote by George Ellis, a physicist, on top and a cosmologist on here. He said, I can construct for you a spherically symmetrical universe with Earth at its center, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds. In my view, there's absolutely nothing wrong in that. What I want to bring into the open is the fact that we are using philosophical criteria in choosing our models. A lot of cosmology tries to hide that. So here's a quote. No physical experiment ever proved that the Earth actually is in motion. Lincoln Barnett, the universe, and Dr. Einstein. So, and a lot of you have seen these quotes. To the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments, meaning as to the question of whether or not we can actually detect or perceive the alleged motion of the Earth in an experiment on the Earth, we've already remarked that every attempt of this nature led to a negative result, meaning we weren't able to actually ever detect, perceive, or measure the motion of the Earth that is assumed. Before the theory of relativity was put forward, it was difficult to become reconciled to this negative result. That's Albert Einstein, Relativity to Special and General Theory, 1920, page 61. He then explains that the struggle so violent way back in the day between Ptolemy and Copernicus would really be meaningless because either coordinate system could be used with equal justification. I, of course, challenge him on that. You have to verify the validity or justification for the idea that it's moving. We know that the stationary Earth can be used with justification because that's how we use the Earth for everything, right? But anyway, this is a hostile witness, and he says the two sentences, quote, the sun is at rest and the earth moves, or the sun moves and the earth is at rest, would simply mean two different conventions concerning two different coordinate systems, Albert Einstein and the Evolution of Physics, 1938. And here's another quote from Einstein, just to kind of break some of these quotes down and give you guys context, go straight to the source. Of course, relativity is still used to this day as the glue for this entire claim that we're flying through space and just can't tell. So he says, while I was thinking about this problem in my student years, I came to the result of Michelson-Morley experiment. Soon I came to the conclusion that our idea about the motion of the Earth with respect to the ether is incorrect. If we admit Michelson's null result as a fact, this was the first path which led me to the special theory of relativity. Since then, I've come to believe that the motion of the Earth cannot be detected by any optical experiment, though the Earth is revolving around the sun in the context of Michelson-Morley, and using the word optics, that would be utilizing light, which is the most precise form of measurement that we have to this day, right? You can use laser interferometry to very precisely measure motion and etc. He's like, so I've come to the conclusion you can't use any optical experiment to detect the motion of the Earth, although I believe we are actually going around the sun. And here he tells you he can't use any, we haven't been able to detect it with any experiment at all on the Earth. Okay. So, in case you don't know, these are some more basics here, but this is the Michelson-Morley experiment. This is a visualization. It's called the most famous failed experiment in history. If they shot 2 perpendicular light beams. One is supposedly going with the motion of the Earth. The other one's supposedly going against it as it flies around the sun. So it should take one of the light beams longer to get to the receiver because it has to travel further. And if that's the case, that's what we should see right here. It should be a difference called an interference pattern or a fringe shift. And what they actually saw was that it's way closer to being exactly the same. But if you look closely, it is not the same. And so what they did, instead of accepting the results saying, oh, we're not measuring this motion of the Earth, we assume, 30 kilometers a second, where supposedly the Earth is supposedly flying through space 30 kilometers every 1 second, which is just 66,000 miles per hour. They said, oh, well, actually the light beams were separated because we are moving, but when we tried to measure it, you just couldn't tell because everything is contracting in relation to the sun. And so basically the apparatus itself, or anything you tried to measure it, it'll contract just the right amount to make it look like the Earth isn't moving. And this is called Lorentz contraction or length contraction. And we're almost through the quotes. Einstein says here, the problem which now faced science was considerable, for there seemed to be only 3 alternatives. This isn't Einstein, but this is a book written about him. The first was that the Earth was standing still, which meant scuttling the whole Copernican theory and was unthinkable. So in response, he's covering a Michelson-Morley experiment here. He said they only had a few alternatives, and the first of which was, oh, the Earth isn't moving. And the Copernican theory is that we are flying around the sun. And he said, and that was unthinkable. So what the evidence actually shows us is unthinkable. That goes back to how this is philosophy, not science. We still need actual evidence, regardless of how much people want to scream, get triggered, and attack you. It doesn't. And so here's a quick little summary of the whole situation, again, from none other than Einstein. But when I was a student, I saw that experiments of this kind had already been made, in particular by your compatriot Michelson. He proved that one does not notice anything on Earth that it moves, but that everything takes place on Earth as if the Earth is in a state of rest.
Okay, so I'm going to wrap it up. That's about it. Hope you took something from that, and hopefully you can share that with somebody. And again, I know that a lot of that was, it's a lot of information. It's a lot to take in. And if you're not aware, the gentleman that I had most of the video, that is Austin Whitsitt. His channel is Whitsitt Gets It, and he's an amazing, remarkable, highly intelligent man who has picked apart the details and is at the forefront of analyzing all of the details of studying what mainstream academia says, and then analyzing reality and putting it together and having never-ending discussions with theoretical physicists, professors, the highest level of academia, and don't take it the wrong way, but he's making them look like school kids, because once you understand all of that heliocentric model is built on philosophical beliefs, there's no foundation, and it's very easy to pick apart because it's not real, and the truth shows itself. So anyways, I'll stop here. Just want to say thank you very much if you watched the whole thing. Obviously, if you're here, you must have. And please share this with somebody. I really wanted to, lay out as best I can, kind of an overview of what we see in the sky, and an overview of what the model really looks like. And it is something that there's a lot of unknowns, but there are a lot of things that we have figured out. And don't be afraid to think for yourself and critically analyze all this information, and stand up for yourself. And this is real. This is very, very real. This is very serious, and it's wonderful. And I'll end this to say thank you God and Jesus Christ and this amazing creation. And this is something that's taken me, this beautiful place that God has given us to live. It should be respected, and His creation should be respected and held in high regard. And these idiots came up with an alternative theory of God's creation of the Genesis account of creation, and came up with a Big Bang leading to evolution and the heliocentric model. It's all one alternative to the biblical Genesis model, which is the only thing that's actually testable, reproducible reality. So, love you. Take care. Okay, I'm going to cut out here.